Very good afternoon to all of you. Welcome to the physics live class. So, in continuation of the chapter we have started, that is work, energy, and power. We are going to study about the conservation of energy. Some things we have already discussed. We are going to take an illustration how the energy, means mechanical energy, is going to be conserved. Okay, so let's take example for that. So, this topic is your conservation of energy. So, in the conservation of energy, if we are talking about the example, so let's say a ball is dropped from height h from the ground, and we wish to calculate energies, means kinetic energy K and P at different point पे बच्चे हम लोग को निकालना है. Let's see it. Suppose this is the ball which has been dropped from here. The initial velocity will be 0 here, and it is at height h. This is height h from the ground. So at the point A, this is, let's say, point A, and this is point B, which is at x distance from the height h, and this is point B, and at the ground this point is, let's say, C. So we are willing to calculate the kinetic and potential energy at these 3 points, and we are willing to see what will be the total energy at the point A, B, and C. So you tell me, bache, what will be the kinetic energy at point A? You know, when any ball is dropped, the initial velocity will be 0, na? Isn't it?
Yes, sir.
So the kinetic energy for this will become
0.
Yeah. And the potential energy at point A will become how much, bache?
So mgh.
Yeah, mgh. And what about the total energy? This is
mgh.
K, yeah, that is fine. K plus P at A. This is K plus P at A. This will be mgh. Okay? Okay. Let's see
Yes.
what will be the kinetic energy at point B. So first we should find out the velocity of a object which has been drawn, which has just dropped from height h at x. The velocity will be using the equation of motion. Which equation of motion? The third equation of motion. V square u square plus 2gx. So the initial velocity will be 0. Velocity at point B, square of this is nothing, it's a 2gx. Means Vb square is equal to 2gx. So kinetic energy at point B will be how much? Half m Vb square. So value of Vb, this will be half m, and this will be 2gx. 2 cancel out, and it will be mgx. This is the kinetic energy at point B. And what about the potential energy at point B? So what will be the potential energy at point B? So you can see the height of this will be your h minus x from the ground.
X.
So potential energy will be how much? Mg
H minus x.
Yeah. And the total energy at point B will be how much, bache? This is kinetic energy at B plus
mgh minus x.
Yes. So kinetic energy is nothing. It's a mgx. And the potential energy is your mgh minus x. Whenever you will solve this, this will be total energy at point B will be your mgh. Isn't it? है कि नहीं बच्चे बताओ? हाँ जी.
Yes, sir.
Okay. So कमिंग टू द पॉइंट सी, अगर बच्चे पॉइंट सी पे मैं बात करूं तो पॉइंट सी पे भी वेलोसिटी निकालते हैं. हाउ वी कैन फाइंड आउट द वेलोसिटी एट पॉइंट सी? दिस कैन बी कैलकुलेटेड यूजिंग द थर्ड इक्वेशन ऑफ मोशन. vc square is equal to u square plus 2gh, and the u will be 0. This u is going to be 0, so velocity at c square means velocity of square at point C will be 2gh. So kinetic energy at C will be half mvc square. We can put the value here, and this will be your half m, and the vc is your 2gh. You can see from here 2 is cancelled, and the kinetic energy at point C is your mgh, and the potential energy at point C will be, this will be 0 because the height is 0, and the total energy is kinetic energy at C plus potential energy at C should be equal to mgh. So from these equation, you can say that the total energy is going to be constant. The total energy is going to be constant. Okay, you can see now at point A and at point B, at point C, the total energy is what? That is a sum of kinetic plus potential energy is going to be constant. Isn't it? Isn't it? Is it clear or not? Is
Is
it
it clear?
okay?
Yes, sir.
So this was the case you have studied in class 9th as well. Okay, this is the case you have studied in class 9th. Okay, now once again we have revised these things. Okay, so now coming to the another very important topic of work energy power, that is a vertical circular motion. So let's see what is basically vertical circular motion and what are the things that has to be determined in vertical circular motion. Vertical circular motion. So if we are talking about the vertical circular motion, so the motion, circular motion can be of two type, means it can be your horizontal, it can be your vertical. So this is all about vertical circular motion, means it is something like this. If you are just taking a stone and you are just tying your stone with a thread, और उससे थ्रेड से बांधने के बाद बच्चे आप उसको ऐसे रोटेट करिए, मतलब हॉरिजॉन्टल पे नहीं, अर्थ पे नहीं, अर्थ के ये वर्टिकल प्लेन पे, वर्टिकल सर्कुलर मोशन में इसको मोशन कराना है. तो देखिए हम लोग को क्या क्या फाइंड करना है. तो सबसे पहले थोड़ा थ्योरी इसके बारे में. लेट्स से a stone of mass m is tied with a string of length L and rotated in vertical circular path. So let's take let's have some figure. So let's say there is a stone which is tied m mass and the length of it is L, and it is moving in circular path. The circular path is like this. This is circular path. This is mass m. This is mass m. So these are the some points. Suppose this particle is at here. This particle is at here, making an angle theta degree from here. So you can see from here, the tension force will be acting vertically upward. This tension force will be acting always vertically upward, and the mg is vertically downward. Mg acting is vertically downward, and here the component of this mg will be, if it is theta, because this will be theta because this line is parallel to this line. So this is center O. So this will be your mg cos theta. So using the Newton's laws of motion, bache, and this is moving in circular path with velocity v. ओके, लेट्स सी इट बच्चे कि अगर ये मूव कर रहा है तो आपको पता है बच्चे, जैसे न्यूटन सेकंड लॉज ऑफ मोशन हम लोग पढ़ते हैं कि द नेट फोर्स एक्टिंग ऑन अ पार्टिकल इफ इट इज मूविंग विथ कांस्टेंट एक्सेलरेशन इज F is equal to ma. So if it is circular motion, then net force acting on the particle should equal to the centripetal force, and the centripetal force always acts towards the center. So let's say this is point P. At point P, this will be equal to T minus mg cos theta. So why we are writing T minus mg cos theta? T is acting vertically upward, that is towards the center, and mg cos theta is opposing, and it will be equal to the mv square by L. This is your centripetal force. So the tension, you can say that this tension is going to vary at each and every point. This tension is going to vary at each and every point. So we are willing to calculate the velocity at point A, B, and C. So let's assume when particle reaches at the point C, when this particle reaches at the point C, when it will be at a maximum height, the tension in the string, the minimum tension in the string will be equal to 0. So what we can write, when particle reaches at C, then the minimum tension become 0. एंड अच्छा बच्चे, पार्टिकल अगर सी पे पहुंच जाएगा तो एंगल ऑफ थीटा, एंगल कितना हो जाएगा बच्चे? व्हाट विल बी द एंगल थीटा? सारे लोग सोच, व्हाट विल बी द एंगल थीटा व्हेन पार्टिकल रीचेस एट पॉइंट सी?
So 180.
Yes, exactly. And the theta become 180 degree. So theta अगर 180 डिग्री हो जाए बच्चे, तो पुटिंग दी वैल्यू, हम लोग वैल्यू पुट करेंगे बच्चे, किसकी वैल्यू? टेंशन की वैल्यू, थीटा की वैल्यू इन इक्वेशन 1. पुटिंग वैल्यूज ऑफ टेंशन T is equal to 0 and theta is equal to 180 degree in equation 1. So we can write here T minus mg cos 180 is equal to m. Here we'll write here the velocity at C. So Vc we are writing mvc square upon L. So the tension will be 0, and you know the value of cos 180? Cos 180 is your -1. So once you will put minus here, minus it will become plus, it will be mg, and it will be mvc square upon L, and will be cancelled out. Then velocity at point C will be your under root GL. So the minimum velocity. So the minimum velocity at a highest point during vertical circular motion is under root GL. Okay. So what I am telling, just try to understand it. The minimum velocity, we can write here the minimum. ऐसा नहीं कि इतना ही होगा, इससे ज्यादा भी होगा तब भी हो सकता है, लेकिन जो मिनिमम वेलोसिटी होगी वो इतना होगी बच्चे. द minimum velocity at highest point in circular motion is under root GL. This is the case. Okay. Now, what else we are going to study? We have find two things: the velocity and tension at the point C. Now we are willing to calculate the velocity and tension at point A and velocity and tension at point B. How we can use these? So let's see it how we can find out. So we are going to use the conservation of energy. So what conservation of energy states? The total energy is going to be constant. Okay, the total energy is going to be constant, or you can say whatever the mechanical energy will be there, that will be same at each and every point. So we can write here, using conservation of energy for A to B. So what should be the equation here? The total energy at A should equal to total energy at C. Okay, this energy is going to be constant. So let's say at the point A the velocity is VA. Here the velocity was VC. And here the velocity is, let's say it is VA. So the kinetic energy will be your half mVA square. But the potential energy at this level will be zero. We are assuming it as a reference point. So the potential energy for this object at a height A will be equal to zero. But in case of the total energy at C, let's see what will be. The total energy at C will be how much? Half mVC square, and the potential energy for this, because the height from the ground is 2L, the potential energy will be your mg into 2L. So let's see how we can calculate. We can put the value of Vc from here. So this will be your, you can just cancel out the from both sides, and this will be your half Va square is equal to half Vc. Vc is your under root GL. This is under root GL plus mg2L. Yeah, m will be cancelled out. This will be 2GL. Once you will solve it, 2 to the 4, 5. It's, oh, my mistake. Here there should be no under root. Here there should be no under root. Let me erase it. Okay. So once you will add it, so this will be become your velocity at A is under root 5GL. This is, the minimum velocity. Sometimes the question is asked in this manner: the minimum velocity to complete the circular path. The minimum velocity to complete the vertical circular motion at the bottom is, this is basically under root 5GL. तो बच्चे ये हो गया कि अगर अंडर रूट 5GL के बराबर आप किसी भी ऑब्जेक्ट को वेलोसिटी एट द बॉटम दे दोगे तो वो एल के रेडियस में एक वर्टिकल सर्कुलर मोशन परफॉर्म कर लेगा. ओके, इज इट क्लियर? क्लियर है बच्चे?
Yes.
Okay, so coming to the another aspect, that is we are willing to find out the tension at A. So how we can find out the tension at A? This can be done using the equation 1. So tension at A, tension at A from the previous figure, and the figure was what? Let's see, this is the figure. This was the figure. Right? Here we are willing to calculate the tension. This point is A, and this point was, let's say, B, and this was your C. At the C, this is C, this is B. Okay, so we are just going to find out what we are going to find out. We are just going to find out the tension at A. So at A, the theta will be equal to 0 degree. Okay, and the velocity at A, we have already determined the velocity at A will be under root 5 GL. So we can just simply put the value here. So what we can put the value? So using equation T minus mg cos 180, cos theta is equal to velocity at A mva square upon L. Now the tension at A, the theta is 0 degree. So at A, theta is going to 0 degree, and the velocity is going to be under root 5 GL. You can put there cos 0 is 1. So this will be your M. VA is your 5 GL upon L. LL is going to be cancelled out, and this tension at point A will become how much? This is 6 mg. So the tension at point A will become 6 mg when any particle rotates in a vertical circular path. Okay, when any particle rotates, then the tension at the bottom will be your 6 times of mg. Okay, now we are willing to find out the velocity at point B and tension at point B. So what we'll write here? We'll write here using conservation of energy, conservation of energy from A to C. अगर A से C के लिए कंजर्वेशन ऑफ एनर्जी यूज करेंगे बच्चे तो क्या हो जाएगा? व्हाट वी कैन राइट, टोटल एनर्जी at A must be equal to total energy at C. So the total energy at A, how much will be the total energy? This is kinetic energy at A plus potential energy at A. This must be, so it should be B. It should be A to B here, because velocity at B हम लोग determine करना चाहते हैं बच्चे. So this will be kinetic energy at B plus potential energy at B. So kinetic energy at A के लिए हम लिख सकते हैं बच्चे हाफ mva स्क्वायर. पोटेंशियल एनर्जी एट ए 0 हो जाएगा बच्चे. काइनेटिक एनर्जी एट बी लिख सकते हैं हाफ mvb स्क्वायर. Potential energy is at point B. You can see this height from the ground is L. So the potential energy at point B will be mgl. And now we can put the value of VA. VA is your 5gl. So this will be M. This is 5gl and this is half mvb square plus mgl. MM cancel out from both sides. This will be your 5/2 GL minus this will become this side GL is equal to half VB square. So whenever you will solve it, you will get VB is equal to this VB, velocity at point B. So this will be 3 under root 3 GL. This is a velocity at a point B. In the similar way, we can find out the tension at point B. How we can find out the tension at point B? So look here, using equation. Which equation? This equation, T minus mg cos theta is equal to mv square by L. So we are willing to find out tension at B. So at B, what will be the case? At B, theta is going to be 90 degree and velocity at B will be your under root 3 GL. Once we will put the value in this equation, T at B minus mg cos 90, and this is going to be your mv square by means mvb square by L. We can put the value of VB, and cos 90 is 0, so tension will be your m, and the VB is your 3GL upon L. LL will be cancelled out, and the tension at point B will become 3 mg. This will be your 3 mg. Okay, is it clear to all of you? So what we have determined till now, we have determined the tension velocity at point A, B and C using the conservation of energy. Okay, so let's see. Sometimes the question is asked like this कि बच्चे जो छोटा अगर ब्रिज बनाना होता है, छोटा सा, अगर मान लीजिए 2 पॉइंट्स के बीच में एक लाइन जोड़ के, तो वो एक कॉनकेव या कॉन्वेक्स सरफेस का क्यों बनाया जाता है, कॉन्वेक्स सरफेस का क्यों नहीं बनाया जाता है? इस तरह से क्वेश्चन आता है ना? मतलब इस शेप का क्यों बनाया जाता है, इस शेप का क्यों नहीं बनाया जाता है? अगर मान लीजिए ऐसे बच्चे कि अगर मान लीजिए ये 2 पॉइंट्स है बच्चे, अब इनके बीच में ब्रिज बनाना है, तो 2 तरीके हैं. एक तो ये बना दिया जाए ऐसे, और एक तरीका क्या है बच्चे? एक तरीका है कि यूं बना दिया जाए. तो कौन सा प्रिफर किया जाता है बच्चे? ये छोटे के लिए मैं बता रहा हूं, कौन सा प्रिफर किया जाता है? दिस वन इज प्रिफर्ड.
ये वाला.
कौन वाला? फर्स्ट वाला.
सर फर्स्ट वाला.
आयुष केसरी ना?
यस सर.
ओके, हाँ, यही वाला बच्चे प्रिफर किया जाता है. क्यों प्रिफर किया जाता है? ये कोई रीजन है? यस बच्चे, देयर इज अ रीजन. यू ट्राई टू जस्ट अंडरस्टैंड इट. ओके, क्या रीजन होता है बच्चे? कि अगर बच्चे कभी भी 2 चीजें होती हैं कि अगर आप कर्व सरफेस पे हैं, अगर ये है यहाँ पे ऊपर की तरफ है इस पॉइंट पे, तो mg will be always acting inward and reactionary force will be always acting outward. और in this case also बच्चे, अगर यहाँ पे कोई ऑब्जेक्ट है तो mg will be always acting downward and reactionary force will be always acting upward. बट बच्चे अब देखिए, सर्कुलर पाथ देखिए, ये ऐसा है तो सेंट्रीपिटल फोर्स तो हमेशा अंदर की तरफ लगेगा ना. तो जो सेंट्रीपिटल फोर्स होगा बच्चे, वी कैन राइट लाइक दिस, mg माइनस r शुड इक्वल टू mv स्क्वायर बाई L, and the reactionary force will be how much? The reactionary force, you can see from here, the reactionary force will be mg minus mv square by L. But in this case, you can see the r minus mg is equal to mv square by L, because the net centripetal force will be acting towards the center, and this reactionary force will be your, बच्चे, r is equal to mg plus mv square by L. तो बच्चे रिएक्शनरी फोर्स अगर ज्यादा होगा तो ये इजिली ब्रेक कर जाएगा, ये बहुत जल्दी ब्रेक कर जाएगा. तो हम लोग प्रेफर किसको करते हैं बच्चे? इस शेप को प्रेफर करते हैं। क्लियर है ये बच्चे? हाँ बच्चे, ये क्लियर है? यस, लेट मी नो। Yes, anyone?
Again, sir. Once
Sir, once
again.
more.
Once more? Yes, once.
Yes, sir.
Okay. बच्चे, कभी भी सर्कुलर मोशन होता है, whenever circular motion take place, then the net force should act along the center. जो net force होना चाहिए, that is your centripetal force. वो centripetal force कहाँ काम करना चाहिए बच्चे? That should always act towards the center. वो center की तरफ काम करना चाहिए, ठीक है ना? तो अगर center की तरफ काम करेगा तो ये देखिए बच्चे, अगर इस शेप की मैं बात करूं तो देखिए ये पहले तो mg नीचे की तरफ, रिएक्शनरी फोर्स ऊपर की तरफ, यहाँ भी वही चीज हो रहा है, लेकिन इसका जो नेट फोर्स होगा बच्चे, दैट शुड बी इनवर्ड। तो भाई जिस डायरेक्शन में नेट फोर्स है बच्चे, उस डायरेक्शन आप फोर्स को पॉजिटिव लेंगे, और जो इसके अपोजिट डायरेक्शन फोर्स है उसको नेगेटिव ले लिया, एंड दिस शुड बी इक्वल टू mv स्क्वायर बाई एल। दिस इज सेंट्रीपिटल फोर्स। सो रिएक्शनरी फोर्स को हम यहां से लिख सकते हैं बच्चे, क्या? mg माइनस mv स्क्वायर बाई एल। और इस केस में देखिए बच्चे, जो नेट फोर्स होगा, सेंट्रीपिटल फोर्स होगा, दैट विल बी ऑलवेज एक्टिंग टुवर्ड्स द सेंटर। अगर वो सेंटर की तरह काम कर रहा है बच्चे, तो इसका मतलब जो उसकी डायरेक्शन में फोर्स होगा, दैट विल बी टेकन एज अ पॉजिटिव। सो रिएक्शनरी फोर्स इज गोइंग टू बी पॉजिटिव हियर, और अपोजिट डायरेक्शन में क्या लग रहा है बच्चे? mg लग रहा है। तो व्हाट वी कैन राइट, r माइनस mg इज इक्वल टू mv स्क्वायर बाई एल, और रिएक्शनरी फोर्स इधर चला जाएगा। तो मतलब यहाँ पे इस केस में रिएक्शनरी फोर्स ज्यादा लगेगा बच्चे, और इस केस में रिएक्शनरी फोर्स कम लगेगा। अगर रिएक्शनरी फोर्स कम या ज्यादा होगा बच्चे, तो उसी के अकॉर्डिंग वेट ऑफ द ऑब्जेक्ट भी बदलेगा। अगर वेट ऑफ द ऑब्जेक्ट बदलेगा, अगर कहीं वेट ज्यादा हो जाएगा तो उस पर फोर्स ज्यादा लगेगा, इसका मतलब वो बहुत जल्दी टूट जाएगा। इज इट क्लियर नाउ?
Yes, sir.
Okay.
Yes, sir.
Okay. So coming to the another topic, that is a spring force. Let's discuss about bache, what is a spring and how this is going to be act, and what is relation between force and displacement in the spring. Okay, and what are the energies that are you can say stored when spring is stressed or compressed. जब किसी भी स्प्रिंग को स्ट्रेच कर देते हैं या कंप्रेस कर देते हैं, तो कितनी एनर्जी इसमें स्टोर हो जाती है। उसके अलावा हम लोग देखें बच्चे कि अगर हम स्प्रिंग पे फोर्स बाहर की तरफ लगा रहे हैं, तो स्प्रिंग किधर फोर्स लगाता है, तो वो स्प्रिंग फोर्स डिस्प्लेसमेंट से कैसे कोरिलेटेड होता है, और उनकी पोटेंशियल एनर्जीज बच्चे कैसे होती हैं। कैसे होने का मतलब ये हो गया कि कैसे वेरीज करती हैं, कि अगर फिर इसमें हम लोग देखेंगे बच्चे एक्सट्रीम पोजीशन क्या होता है ना, और मीन पोजीशन क्या होता है। एक्सट्रीम और मीन पोजीशन में उसकी काइनेटिक और पोटेंशियल एनर्जीज क्या होती हैं। इन सब चीजों को हम लोग अभी स्प्रिंग फोर्स में डिस्कस करेंगे। ओके, तो स्प्रिंग फोर्स, सो